Hello, welcome to Embodied Carbon 101, brought to you by the Building Innovation Hub. My name is Kai Starn. I'm a senior sustainability consultant with Stephen Winter Associates. Our sustainable building team supports various green programs, providing on the ground experience to design, construct, and operate buildings more sustainably. In this short primer, we'll cover what embodied carbon is, share an example of a useful tool called EC3 for selecting materials, and additional resources to help understand this important and growing topic. Operational and embodied emissions account for 42% of greenhouse gas emissions worldwide. 15% of those emissions come from extracting, manufacturing, and transporting those construction materials. This is a significant amount of emissions contributing to climate change, increasing climate risks, but also emissions that design teams, through intentional, efficient design, can directly improve. The American Institute of Architects, or AIA, made a 2030 commitment to help empower people in the building industry to start taking accountability for emissions, to track them, and to see where and how they can make an impact. But first, let's define what we're talking about. Embodied carbon represents all the emissions that occur to construct a building, like what it takes to transport and replace or demolish the construction materials. Operational carbon is the emissions associated with the building's actual energy consumption, like electricity and gas. Our example today looks at embodied carbon. Early in design, it's essential to set project goals and communicate the intent to the entire team, including construction team. One way to do this is to include the exact materials the team wants in the specification book or spec book, so all the building materials that are going into the building are vetted throughout design. Other human and environmental attributes, like known carcinogenic materials, can also be vetted. So what carbon emissions are included? Here you see the life cycle stages of ready-mix concrete. The stages circled in blue are the upfront carbon of the concrete, often called the carbon footprint. That's associated with the extraction, the manufacturing, the transportation of all the components of that material to the site. Upfront embodied carbon often contain the most emissions in a material, but it's not the whole picture. The other life cycle stages here represent the upfront emissions plus the anticipated replacement of materials, like when there's a renovation, and how the materials will be disposed of or reused at the end of the life cycle. Programs like LEED assess all the stages shown here in what's called a life cycle assessment, or LCA, while other programs may only look at the upfront carbon. Starting early in design, developers and designers can take steps to reduce embodied carbon. Often the first question in the earliest stages of development: can the building or structure be reused to avoid the greatest number of emissions, because the structure, concrete, and steel and glass are the most significant emitters. If the building is new construction, the most improvements can be evaluated using a life cycle assessment of the entire building. The LCA allows designers to evaluate ways to make the design more efficient with fewer materials and pinpoint which material substitutions are most impactful. Next, we specify and recommend product alternatives with lower embodied carbon. So, how do we begin to evaluate products? There are a growing number of resources to make it easier for designers who must weigh many factors, and these tools make it quicker and easier to evaluate. The industry is being transformed by designers and owners demanding material transparency and programs like LEED and federal and local rules that require disclosure of impacts. EC3 is a tool made by the Building Transparency Organization. It's an online tool, free currently, and one of the important tools to aid research in materials. Here we've chosen a specific building product, ready-mix concrete. The tool allows you to select material type, region, which is important, and performance criteria. It's going to pull up all the ready-mix concrete products from different manufacturers at different plants that have embodied carbon data available in your area. On the far right, we can see and compare the kilograms of carbon dioxide equivalent, it's the common metric for embodied carbon, per 1 cubic yard. I can sort from the lowest to highest embodied carbon. Here I see products in the 300s, but I have no idea if this number is good or bad. So that's where this tool becomes really helpful. Under the statistics section, I get a frame of reference for these numbers. So I can see the average is a little below 300, and then what is achievable or realistic at this point is in the 200s. So it wouldn't make sense for me to look for something below what's achievable. We use this type of data in our recommendations. We've pulled every manufacturer, product specified in the building and ranked them, either good, better, or not recommended. Here I'm showing a snip from a foam board installation, where 7 products, as you can see bolded, were specified. We pulled EC3 data for these and gives us a frame of reference on how to make our recommendations. Significant policy drivers include local initiative is the Maryland Department of General Services. This requires projects to collect and share a standard life cycle report for a material called an Environmental Product Declaration, or EPD, for concrete. These examples of buy clean policies are becoming more frequent in other jurisdictions. In conclusion, we see more and more architects and owners asking for sustainable materials and embodied carbon services to support everything from company pledges like the AIA 2030 commitment to lead in municipal policies. So thanks for taking the time to join us, and we hope you find the information helpful.